welcome to today's session. My name is Dmitro Polishchuk, and this is our next DBT Talk expert session. This time, our session will focus on DBT Snapshots as sources for Data Vault-powered enterprise data warehouse. This will be the second session on DBT Snapshots. The first took place on November 7th last year, where we covered the essentials of snapshots, how snapshots are defined, configured, and built in DBT. Now I will dive into a practical example, exploring how snapshots can be used as sources for the Data Vault data warehouse. For those of you who are new, I would like to say that a couple of words about DBT Talk Hub and Speak. We make these sessions on every first Thursday of every month, where we discuss various topics related to a transformation tool, DBT, as well as DBT Cloud and DBT package, Data Vault for DBT, made and supported by skill-free developers. I do these sessions in turn with my colleague Erna Nervale. If you would like to have a DBT session on some particular topic or functionality, you can send your questions up front by filling out a form on our website, scalefree.com/dbttalk. This topic was inspired by a viewer's question: how can you build a Data Vault data warehouse downstream from DBT Snapshots? So therefore, I choose this topic for today's session, since I already covered snapshots in one of my latest sessions of the DBT Talk. So let's start with the topic. A few words about myself first. My name is Dmitro Polishchuk. I'm a senior BI consultant at Scalefree. I've been working for Scalefree for almost 3 years. In general, I have experience in data warehousing and business intelligence since 2017. In particular, in consulting and implementation of data warehouse BI solutions for different industries, retail, digital, finance, and others. From the educational side, I did a bachelor in finance and financial management, and then I did some further certifications, CDV P2 or Certified Data Vault 2.0 Practitioner. I also have Microsoft certification related to data engineering on Microsoft Azure. I also have Snowflake core certification, and the latest one is the certification related to the DBT Cloud administration. My core competencies in data warehousing are data engineering, Data Vault 2.0 modeling, Data Vault automation, and also dimensional modeling. Let's get started. First, let's take a quick moment to refresh our understanding of what DBT snapshots are. A snapshot in DBT is a tool that captures and preserves changes in data for tables that may be updated over time. Snapshots essentially act as history-preserving feature. Snapshots allow analysts to look back and see what a row looked like at previous points in time. This is particularly valuable when working with mutable tables, which often serve as a source tables in DBT, where data points like customer attributes might be updated frequently, and we need to analyze or report on historical states. Snapshots in DBT are built on the concept of type 2 slowly changing dimensions, which track the history of changes to each row. Snapshots are essential for scenarios like auditing, where we need a reliable record of data states, regulatory compliance, where a history of changes might be legally required, and historical analysis, where we want to understand how data evolved over time. The snapshots are run with the command DBT snapshot. They're also a part of the DBT build command. It's important to note that snapshots cannot be rebuilt in the direct way in DBT, and this is by design to prevent accidental deletion of the valuable historical data. DBT takes the original structure of a table for a snapshot and adds 4 metadata fields to it: DBT SCD ID, DBT updated at, DBT valid from, and DBT valid to, that provides technical information about the change. The names of these fields are customizable starting from version 1.9. Also, DBT offers 2 snapshotting strategies: timestamp and check. The timestamp strategy relies on the updated add column. This strategy is recommended in DBT because it's straightforward and highly performant. It only captures a change when the timestamp value changes. On the other hand, the check strategy is useful when there is no reliable timestamp column in the source. Here, DBT compares specific or all columns in each row and updates the snapshot if any of these columns differ from the previous version. It's flexible but less performant. DBT also allows optional tracking of hard deletes by setting invalidate hard deletes to true. This feature is not enabled by default. With this setting enabled, if row is missing from the source data, DBT will update its DBT valid to timestamp, marking the record as no longer valid. Tracking hard deletes is very important for activity satellites in Data Vault, which we will review during the demo session. And for this DBT talk session, I built a small Data Vault style data warehouse that sources data from Snowflake sample database. These data sets are provided by Snowflake for testing complex queries on a large-scale business-related data. You can find the documentation link at the bottom of this slide if you would like more details. The data set consists of 8 base tables with predefined relationships, but I selected 4 key tables as source tables: customer, orders, part, and a line item. For each of these source tables, I created a corresponding snapshot, and all these snapshots are to be served as persistent staging area, or PSA, for our data warehouse. I used check strategy since the source tables don't have a reliable timestamp columns. I also enabled invalidate hard deletes to true, which, as already mentioned, is crucial for effectivity satellites, which we're going to review. Although I included only 4 tables from the Snowflake dataset, my focus during the demo will be primarily on the customer table. I will make changes to this table to demonstrate the core principles of using snapshots as sources for Data Vault data warehouse, and all those principles are applicable to every part of, so basically to every table, orders, parts, and line item, and to other tables that might be added to this schema. The target row data vault consists of 3 hubs representing business objects: customer hub, order hub, and part hub. We also have 2 links: orders link, which captures relationships between customers and orders, and orders parts link. This is a dependent chant link detailing order line items. There are 4 regular satellites. 3 store attributes for the hubs, customer, order, and part, and 1 is attached to the orders parts link. Additionally, there are 4 effectivity satellites storing DBT valid from and DBT valid to timestamps from the snapshots. These are treated as attributes but kept in separate satellites. I will focus on the customer part of this data vault module during the demo as well. So we will look at how changes made to the customer source table will be reflected in the customer satellites. And all the Data Vault entities in the demo data warehouse were built using Data Vault for DBT. This is an open source package developed and maintained by Scalefree. This package simplifies the implementation of Data Vault 2.0 within DBT. Data Vault for DBT adheres to the official Data Vault standards. It is designed to work seamlessly across multiple database engines, including Snowflake, Google BigQuery, Amazon Redshift, PostgreSQL, Microsoft Fabric, and more. The package comes with extensive documentation covering general usage, adapter-specific considerations, macros for loading nearly all Data Vault entities, and guidelines for testing Data Vault implementations. So I highly recommend you trying Data Vault for DBT in your DBT-powered Data Vault projects. Now it's time for the demo. I will stop sharing my screen for a moment. I prepare a small demo DBT project to showcase how DBT snapshots can be used as sources for a data vault-driven data warehouse. So let's look at the sources first. The sources are the copies of those 4 sample tables provided by Snowflake, which I mentioned during the presentation. I copied them into a separate schema in a demo database, DBT Talk demo, to be able to make changes and check how they are reflected in the data warehouse. So now let's check snapshots. So there are 4 snapshots configured in the YAML file. Snapshots for customers and parts refer to the sources directly, whereas line item and orders refer to ephemeral models. The reason for this is that DBT snapshots require one single unique key column, which is absent from the original orders and line item tables. Therefore, I created those ephemeral models where I define those unique key, one single unique key column. Here, for example, in the orders, I concatenate order key and customer key and create column order ID. And in this SRC line item model, I concatenate 3 keys: order key, part key, and line number into a single column line item ID. And then I configure those columns as unique keys for these snapshots. Now let's also check the general snapshot configurations for the whole project. They are set in the YAML, in the DBT project YAML file. Here I configured a separate schema for snapshots. So it's snapshots, as DBT recommends for security purposes and also to prevent accidental deletion. Snapshot strategy check, as was already mentioned, and we're checking all columns. So yeah, and check strategy was chosen because there is no reliable timestamp column in the DBT in the Snowflake source data. Invalidate hard deletes is set to true, to capture deletions and to fill our effectivity slides properly. And lastly, I customized snapshot metadata column names, removing DBT underscore from them, so that we have just valid from, valid to, std ID, and updated at without the excessive prefixes. Now let's run our snapshots and look at the results in the Snowflake. Okay, our snapshots are ready. Now let's review them briefly. Basically, the first time snapshots are run, DBT creates, so DBT makes a copy of the original source table and then adds these 4 metadata columns at the end of the table. So it's, for example, here you can see is a snapshot for customers. This is the snapshot for orders. So it's basically the copies of the original tables. It's a part, snapshot for parts, and snapshot for line item. Now I'm going to draw the focus on making changes to a customer. Namely, I'm going to make several changes to the customer source table and run the DBT snapshot command after each change, so that we have some history in the snapshot table to work with. So now I'm going to, I chose the customer with the customer Q1 to make changes to, and now as a first change I'm going to update the customer phone number. Now let's see how. So this is how this row looks like in the original source table, and this is how this row looks like in the snapshot. Now I'm going to update the customer number. Let's check that the change took place. So the customer phone number is updated, and now I'm going to run our snapshot for customer. Okay, DBT changed to 2 rows. Let's see at the result. So this is how the change was reflected in the DBT snapshot. Here we have two rows. The first row with the original phone number was updated, so namely valid 2 was updated, and then at the same time a new version of the row was inserted with a new phone number. Now I'm going to delete this customer from the source table. Yeah, now let's check that this customer is absent. Now I'm going to run the snapshot again. Okay, let's check the result in the snapshot. Okay, so the DBT just, in this case, DBT just updated valid 2, marking that this row is no longer valid. Okay, and now I'm going to add this customer back again, restoring the original values for this customer. And now let's run this snapshot again. Let's look at the final result in our snapshot after all these changes to see how the history has been reflected there. So just to recap, the initial row was inserted at 12:15 as stated in updated at and valid from. Then valid 2 was updated to 12:17 and a new row inserted at the same time, reflecting the new phone number. Then valid 2 was updated to 12:18, marking the time of the deletion. And finally, a new row was inserted at 20:18, but a few seconds later, after we added our customer back to the source table with the original phone number. At this point, I can say that this snapshot cannot be used as a source for our data vault data warehouse directly as it is. The reason for this is that there is not one, but rather two timestamp columns reflecting changes in the data. Updated at or valid from, so these columns aren't identical, when a row is inserted, and valid to when the row is updated. Ideally, we need to have one single column for a timestamp reflecting both types of changes, inserts and updates. Additionally, it would be great if any change was reflected as a new row in our snapshot so that we can see the extended or full history of changes. To achieve this, I created a view on top of the customer snapshot. So this view, I named it SnapX Customer. Let's look at how the changes for our customer were reflected in the extended snapshot. So first I need to build this snapshot in our DBT, or at least run it. So it's materialized this view on top of our snapshot. Let's see what we get here for customer one. So every change in this view gets its own row, like the original row for our customer with empty valid to value, as well as the row with the valid to updated. And at the same time, we get a new row with a new phone number. So as the next row. Then the next row with the valid to column updated, reflecting the time of the deletion. And finally, the last row shows the time when our customer was added back. Here, the column updated at represents a timestamp for the respective operation, insert or update at every step. Now, very important note here is that these two rows with old and new phone number have identical updated at values. This is not good because in this case we cannot guarantee that these two rows will be processed in the proper order when loading the customer satellites, which we'll review shortly. This can lead to false deltas in our satellites. To address this, I created a separate column LDTS, stands for load date timestamp, where I handle this case by adding a millisecond for the second row with the phone number, with a new phone number, to force the proper loading order. Now let's look at the definition of this view. Here I unionize the updated rows of the snapshot, where picking the rows with value to updated that are not now, and I unionize this with all all rows with the same snapshot, applying some simple logic to updated add here, and leaving value to blank below to restore the original view of the row. And finally, I calculate column LDTS by adding a millisecond to the second occurrence of the same updated add value to force the proper loading order. So I do this with the help of window function row number. So this extended view is going to be the source for the data vault staging view. And this is our data vault staging view for the customer, where we calculate the hash key for the customer and hash diffs for the customer satellites. So it's the regular satellite, hash diff for the regular satellite, where we store the descriptive attributes like name, address, phone, phone, and a marketing segment, and also the effectivity satellite. For this, I'm taking values from valid to and valid from. We consider them as descriptive attributes, but put them into a different satellite. This staging model is generated with MicroStage from package data vault for DBT. Let's briefly review also the customer hub. It's not of very importance in the context of the changes, but still. The model, our staging model is chosen as a source. Not chosen as it acts as a source. This model was just reviewed, and also we take customer business keys from staging model for orders. So because this model contains customer keys as well in the context of their relation to orders. Here we also specify the name of the hash key column here, customer hash key, and the name of the business key column is customer key column. Now let's review the customer satellites version 0. Customer satellites version 0. So version 0 means that the satellites should be materialized as incremental tables, and macro satellite version 0 is used for that. This is a regular satellite. This is a regular satellite for descriptive attributes. Which is loaded with the customer hash key and hash diff from our attributes, which are also loaded into this satellite. So this is our descriptive attributes. And effectivity satellite. So it's basically looks almost the same, except for that for this satellite we take only valid from, valid to, and hash diff is calculated based on these two columns, and the name of the hash diff and hash diff columns has another name. And version 1 satellites. So this is version 1 regular satellite. This version 1 satellite is built on top of the version 0 satellite, and this in this satellite we calculate virtualized load and date timestamp, and optionally is current flag. This flag marks a currently valid row for every hash key in the satellite. So this model is generated with satellite version 1 macro, and so the customer effectivity satellite version 1 is built in almost exactly the same way, except for that we take another source satellite and another hash diff. I'm going to build those data vault models that we just reviewed. I'm going to build those models starting with our extended snapshot. Okay, now let's briefly look into the generated data vault entities for the customer in Snowflake. So it's a customer hub, which is filled with all the business keys, customer keys. This is our customer one, and here we have a regular satellite. So this is regular satellite version 1 for our customers, and I also joined it with the hub to be able to filter based on the customer key. And here it contains the history of changes of the descriptive attributes, like the phone number. For example, here you can see that the phone number was the original value for the phone number, the change value, and then the original value again after we added our customer into the source table. Then the version 1 of the satellite looks exactly the same, except that we have two additional attributes calculated, like load and date timestamp, and is current attribute that marks the currently valid records with true. Our effectivity satellite looks like this. Here we have all the changes of valid from valid to. And the version 1 of our effectivity satellites looks exactly the same, but with those load date and date timestamp is current attributes calculated on the fly. And last but not least, I created a business effectivity satellite on top of our effectivity satellite version 1. Here, I will just run it for our customer 1. In this satellite, we calculate attribute is active based on valid from and valid to attributes from the effectivity satellite. Only the rows are kept that reflect changes in activity. Other intermediate changes, like, for example, changing a phone number, are filtered out. So this is what basically what can be built on top of our effectivity satellite, and that I just found it quite useful. And let's look at the definition of this business effectivity satellite for customer. So here I calculate this is active attribute in the first CT. Then here I calculate in the second CT I calculate is active previous value of the is active attribute. And in the third satellite, I just filter out rows where is active changes. I only filter out that the rows where is active doesn't change. So keeping only the changes. Then here I will calculate load and date timestamp. And the last we calculate is current attribute. So yeah, this is how it looks like. And this was it for the customer part of the data model. All other parts of the data vault model related to orders, parts, and line items are created exactly the same way, starting from creating these extended snapshots and adding with these business data vault entities like a business satellite that we just reviewed. Since the DBT snapshots in this case represent persistent staging area, or PSA, and keep the history of changes, they can be used for incremental loads as well as for the full reloads of the dependent data vault entities, producing the same result. So this was it for the demo. I will stop sharing my screen for a moment. So just a small recap. In this session, we refreshed our understanding of what DBT snapshots are, how they are defined, configured, and built in DBT. And then during the demo, we looked into a small data vault-based enterprise data warehouse prototype that I prepared to showcase how DBT snapshots can be used as sources for data vault-based data warehouse. I did several changes in one source table that were reflected in a snapshot. and then in the satellites. The provided approach allows for tracking the changes incrementally as well as a full reload of the historical data into our data vault entities, especially satellites. And I also would like to mention that SCAL3 has a variety of trainings available. Some of them might be relevant for your projects. For instance, we have one related to DBT and Data Vault 2.0. In this training, you will learn DBT even if you have no experience with this tool, and also Data Vault 2.0, which is one of the main areas of our expertise here at SCAL3. So I think this training may not be the best, may be the best combination for those who would like to learn the Data Vault 2.0 methodology together with the tool for its implementation. Additionally, we have other trainings, the one related to Data Vault 2.0 automation with Veriscape. For those of you who are interested in working with Veriscape, which is one of the alternatives to DBT. And finally, the one related to the agile data warehousing and the example of how it's applied to the development of Data Vault powered enterprise data warehouse. The training is relevant for those who would like to apply agile development in their data warehouse projects to bring them on a new level. So go to scalfree.com and check those trainings if you are interested. Go to scalefree.com/dbtalk and register for our next webinars. If you would like to have a DBT session on some particular topic or functionality, you can send your questions up front by filling out a form, which can also be found there. So thank you for your attention and see you in our next sessions.